welcome once again. It's Noble Hero. Now we'll be talking on first principle now. Alright, so now when it comes to first principle, you can either use a formula to solve, or you can use you can derive the formula as you're solving through. Alright, so for the formula, it says that dy dx is, or you can say f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x divided by h. So you can use that, or you can solve through conventionally until you arrive at your answer, which is still the same thing. It will still derive end at the same answer. So for instance, you have, now for the conventional method, you have y equals to x raised to the power of 3. Now the first thing you need to do is to take the partial derivative of y plus y. Or you can also say y plus the partial derivative of y. Okay? To be equals to, now your x here is raised to the power of 3. But now you're going to make the change in x. So we're going to put x plus the little change in x. Okay? Now the whole of this will represent your x now, and you raise it to the power of 3. So in this case now we've changed our x. We have added a little increase to our x here, just as we have added a little increase here to our y. Okay? So this is how you represent it. And then since you are trying to derive and dy dx, you will have to move the y to the right hand side such that you have dy equals to x plus dx raised to the power of 3 minus y. Okay? Now, since you want to continue the right hand side to be with the same letters, this x, dx, and this now y, we need to change it back to x. You now have to go back to the first equation here and represent your y here with this. So this will become x plus dx to the power of 3 minus x raised to the power of 3. And this will be your dy. Now that you've gotten your dy, the next step would be to divide dy by dx such that you now have the dy dx. So you do the same thing to this side, dx. Now, how does this represent this? Here you have your x plus dx, which is the same thing as x plus dx. And since the function has a power of 3, you will have to make it the power of 3 here, minus f of x. Your f of x is what you started with. Y here represents f of x. Okay? And then divided by h. Your h is your dx here. So you will have to take the limit as dx tends to 0 in this particular case. Okay? So when you take the limit as, and you now have dy dx to be the limit of this equation as dx goes towards 0. Alright, let's have a little recap again on what we're doing, what are we really doing. When you have y equal to a particular this, and we have to add your dy to your y and add your dx to x, and then put it in the same form that it is. So another example would be, for instance, you have y equal to sine of x, and you want to solve that from first principle. Now all you need to do is to change this x into x plus dx. So your y here will be y plus changing y, and this will be sine. Place of x here, you put into bracket and increase it to this. That's how you work on that. And then you know the next step is to move this to the other side. So take note of it. That's the same thing you did here. You move your y to the right hand side. So you will always move your y the right hand side, such that you have your dy equal to sine x plus dx minus y. And then you should also take note again, just like we did here, that we have to change our y here, substitute what we had before. So we're still going to do that again. Take back to this side, y equal to this will have to change again into sine x plus dx minus sine x. And then the last point is to divide both sides by dx. So we'll have to divide both sides by dx. So it follows the same principle, the same steps. Okay? And then after that, you now have to work with your knowledge of trigonometry. So trigonometry identity should be able to help you. The formulas, they should be able to solve this. Okay? So while this one, your expansion of this should be able to help you to solve this equation. Okay? So that was why we learned expansion using Pascal triangle and binomial expansion earlier. So with what you learned before, you should be able to expand this and be able to solve it. All right, so now that we've gotten the idea, let's solve a particular question here and see how it goes. So the question will be, find the derivative of 3x raised to the power of 3 plus x raised to the power of 2 minus 5. Let's say this, what we have to do from first principle. And this is what we're going to do. We're going to start by saying let y be equals to 3 x raised to the power of 3 plus x raised to the power of 2 minus 5. That will be the first thing we're going to do. Okay? Now we're going to change our y here to y plus partial change in y. Okay? Which means that we're going to also change our x to x plus partial change in x. But before we do that, let's start. Here we have what first? 3. So I'm going to write down that 3 first, and then change my x into x plus partial change in x, and then that x had a power of 3. I'm going to do that here, adding the power of 3. So I'm done with this particular first one here. Now I have to move on. The next one is plus. I put it down. You have x raised to the power of 2. Now here, x here will now become x plus change into x square. Then minus, we put down the minus, we have 5. Now 5 does not contain any letter, so we're going to write it that way, just 5. Alright, so now you know the second step is to move your y to the left hand side. Okay? So when you move your y to the left hand side, you are now left with dy equals to, now this, I'm not going to multiply my 3 into this first because this has a power. Until I'm able to break down the power, I shouldn't bring it down. So now let's talk about our Pascal triangle now to use it to solve here. So this, since this has a power of 3, you should take note that the coefficient that you're going to use would be 1, 3, 3, 1. And in this particular case, our A is x, while our B is dx. Alright? Alright, so let's continue now. So I'm going to write down these 3 first and then expand this. First coefficient is 1. So the expansion of this, first coefficient is 1, so I'm not going to write anything. First variable, x, with the highest power, 3. Second variable, dx, with the lowest power, 0. So with the power of 0, the x becomes 1. So I'm not going to write the x again. So plus second coefficient, write down the coefficient 3. First variable, x, power decreases from 3 to 2. The x now increases from 0 at this point to 1. Okay, and then we now go on again. Coefficient again 3. X decreases from 2 to 1, while the x increases from 1 to 2. Okay, and then the last point, and the last point is the coefficient is 1. So I'm not going to write any number here. First variable x decreases again. Remember, it decreases from 3 to 2, 2 to 1, and 1 to 0. And when the power is 0, it's now 1. Now the x increases from 0 here. That's why you don't see the x here, to 1. From 1 to 2, 2 to power of 3. So we're going to have the x with the power of 3. Now we've successfully expanded this now. Successfully expanded this. Now we put in the sign plus, we expand this. Now how do you expand that? Now the power here is 2, and the coefficient that we're supposed to use in this particular case should be 1, 2, 1. Okay? So we start with the coefficient 1. So I'm not going to write any number there. First variable, x with the highest power 2. Second variable with the lowest power 0. So we are not going to see the x in the first point. Now the second point, second coefficient is 2. First variable x decreases from 2 to 1, while the x now increases from 0 to 1. Okay? Now, still expanding this, at the last point, the coefficient is 1. So we're not going to write any number. Now, x has decreased from 3, 2, and then at the last point should be 0. So we won't have x alone. And then the x has increases from 0 to 1 and then to 2. Okay? Then minus 5. Then after that, we now, remember, we move our y to this side. So I have to put minus y. Now let's expand this now. So this should becomes 3 to this becomes 3x cubed plus 9x squared dx, 9x dx to the power of 2 plus 3 dx to the power of 3. Then we write this down. This x to the power of 2 plus 2x dx, then plus dx to the power of 2 minus 5 minus y. What is y? Y is 3x squared plus x squared minus 5. Now, since y is not just one thing, and I've put there minus, I have to put a bracket to put down those things. Okay? So those things are 3x cubed plus x squared minus 5. If I close the bracket now. Alright. So the whole of this is equal to the y, right? Now, permit me to clean this up so that we can continue. Okay, so this is where we were solved to this point. Now, all we need to do now is to subtract this, moving the negative sign into this equation. Alright, so we now say that dy equals to 3x to the power of 3 plus 9x squared dx plus 9x dx to the power of 2 plus 3 dx to the power of 3 plus x squared plus 2x dx plus dx to the power of 2 minus 5. Then minus into this, we have minus 3x squared. Minus times plus, we have minus x squared. Minus and minus becomes plus 5. Alright, so at this point, we now look at like terms. This is like terms. Sorry, it should be to the power of 3. All right, so these and these are like terms, so they're going to cancel out. One is positive and one is negative. All right, now again, like terms, one is positive, one is negative. Then we have 5, one is negative, one is positive, so we cancel out. And then we write down what we have left. What we have left is 9x squared dx plus 9x dx squared plus 3 dx cubed plus 2x dx, okay, plus dx all squared. So this is what we have. Now to both sides, we are going to divide dx to both sides. And if you look at all these points, it all contains the x, so we can factor it out. So if you factor out the x out, at this point you will be left with 9x squared. Factor out the x here. Remember, they still have this, the x squared, so it should be remaining one of it. So we should have something like this. Now this is 3dx cubed. So if you take out one, that should be 3, and the x squared, one is out. At this point, if you take out the x, you are left with 2x. If you take out the x here, you are left with the x. Okay. All divided by the x. Now the x here will cancel the x on the numerator. Okay. When you're done with that, you now have that your dy dx will be, and you can take the limit as the x tends to 0. So which means that anywhere you see the x, you should add 0 to it. So anywhere you have dx, we should insert 0 there. So we now have dy dx to be equal to, here we have 9x squared, and this will be 9x multiplied to 0 plus 3 multiplied to 0 squared plus 2x plus 0. All right, so we know that this point will be 0, this point will be 0, and this one will be 0, and we are left with 9x squared plus 2x, and this would be the answer. All right, so that's how you solve using first principle, and we'll still do more examples so that we can understand better. But for this video, this is where we're going to stop. But and then before we go, please, I would like you to take note of certain things here. Take note of these different functions. Okay, so this y and this dy dx. So if your x is x raised to the power of n, if your y is equal to x raised to the power of n, then your dy dx will be the same as n x raised to the power n minus 1. Okay, so I want you to take note of this. If your y is equal to sine x, your dy dx becomes cos x. If your y is equal to cos x, your dy dx becomes minus sine x. If your y is equal to ln x or log x, the dy dx will be 1 over x. If your y is equal to e raised to the power of x, your dy dx remains as e raised to the power of x. So I want you to take note of this simple form of differentiation. Take note of them, and we'll talk about it later.